Assalamualaikum and hi everyone. This video is about group assignment for MAT560 and our title for group assignment is Green's Theorem. For this group assignment, we provide two questions. So let us give a solution and explanation for each questions. Before that, let me introduce our members first. We have Ilham Maisara binti Hafisham, then myself, Nolida binti Muhammad Yusuf, and lastly we have Siti No Azwaliana binti Muhammad Nozaini. Before we jump to the questions, let me introduce about the Green's Theorem. What the background of the Green's Theorem? Green's Theorem started in 1828 by George Green, and it applies in two dimensions, which is xy plane, and it's also related to line integral around closed curve to a double integral over the closed area. Green's theorem stated that let R be a simply connected plane region whose boundary is a simple, closed, piecewise smooth curve C oriented counterclockwise. If Pxy and Qxy are continuous, first partial derivative on some open set containing R, then so this is the formula for the Green's theorem, which is double integral del Q over del X minus del P over del Y dA, where C is a simple closed curve, a single loop without any hole. Then Pxy and Qxy is a functions representing the vector field, and then del Q over del X and del P over del Y is a partial derivative of P and Q. And then lastly, dA is a area element, which is we can choose dy dx or dx dy. So this is the question that our group provide for group assignment, which is question 1 and question 2.
Okay, so Assalamualaikum. So today I will explain about manual solution for question number 1 and question number 2. So let's go through for question number 1 first. We have several steps in our calculation. So the first step is identify the limit for x and y. So based on the figure, we know that the limit is start from -3 to 0, and we have the function of y equal to x plus 3. So the limit for y is between 0 to x plus 3. Next, identify P and Q. So from the question, we know that P is equal to xy squared plus x squared and Q equal to 4x minus 1. And then differentiate P with respect to y and Q with respect to x. And we will obtain delta P over delta y equal to 2xy and delta Q over delta x equal to 4. So by using Green's theorem, we just replace the differentiate value into the Green's theorem. So we will get integral x from -3 to 0 and integral y from 0 to x plus 3, 4 minus 2xy dy dx, where 4 represents delta q over delta x and 2xy represents delta p over delta y. And the next step is integrate with respect to y. After the integration, just substitute the limit into the equations. And don't forget to integrate with respect to x, since in Green's theorem, double integral involved. So the final answer is 99 over 4. Okay, next for questions number 2, we will do the same step. The first step is identify the limit for x and y. So based on the figure, we know that the limit for x start from 0 to 5, and we have a function for y equal to 2x. So the limit for y is between 0 and 2x. And then identify P and Q. Based on the equations, P is equal to y squared minus 4x and Q equal to 2 plus x squared y squared. Differentiate P with respect to y and Q with respect to x. So we will get delta P over delta y equal to 2y and delta Q over delta x equal to 2xy squared. Okay. Next, replace the differentiate value into the Green's theorem. So you will get the integral x from 0 to x equal to 5 and integral y equal to 0 to y equal to 2x 2xy squared minus 2y dy dx. Integrate with respect to y first and then integrate with respect to x. So the final answer will be 9,500 over 3.
Next, I will show the solution for question 1 and 2 by using Maple software. This is the solution for question 1. Firstly, we let the equation from the question 1 with P and Q. Then, we differentiate for both equation. For equation P, we differentiate with respect to y, and equation Q, we differentiate with respect to x. So, after we differentiate both equations, we integrate the equation by using Green's theorem formula. So, when we use the formula, the limit integral for x and y, we will use it from the equation and integrate with dy dx. So, the answer for the question 1 will be 99 over 4. Next, for question 2, the steps to get the answer are also same as the question 1. Firstly, we let the equation from the question 2 as P and Q. Then, we differentiate for both equations. For equation P, we will also differentiate with respect to y, and equation Q differentiate with respect to x. So, after we differentiate both equations, we will integrate the equation using the limit integral for x and y that we can get from the question. We also integrate the equation by using Green's theorem formula. So, the final answer for the question 2 will be 9,500 over 3. That's all from us. Thank you everyone.